Oh my goodness. I have been prepping for this video. It is what, Thursday night, 7:09. I have a feeling I might run out of time before I can cover everything. Seriously, it's not going to be an exciting video. I wish it was, but we got some stuff to cover, and that stuff is going to be all great study things for uh, the test, which is coming up next week, probably mid next week before that real long, nice little break that we get because you guys, what do we have, like a half day next Thursday, no school Friday, and no school that Monday. So, man, I really want to get that test to you probably on Wednesday. That would be awesome, huh? What's that? You think so too? So do I. All right, so I do apologize in advance. This is going to be super dull, but ton of mathematics and tough stuff that we need to go through in order to get you ready for the test, okay? Obviously, you don't have to have anything memorized anymore because you have it all on your note card, and you better believe that I have mine sitting right next to me right now, ready to go, because I know what I'm about ready to do, and it's crazy. Okay, you remember we stopped there and y'all did this problem and you were finished and then you turned in your homework, right? So I want you to bust out another piece of paper and based on the problems that I'm about ready to do, you might need like 20 sheets of paper. I'm just I'm just saying. All I'm saying is I'm just saying. Okay? So again, I can't apologize. Miss Witter, I apologize because normally my videos are amazing. They just flow. They get the students engaged. They have all that stuff. But today, it's just going to be one of those math days where we just got to go and get through the stuff. Okay, it's like a crunch day. All right. So, all right, Marshall, are you ready? Yeah, you are. Let's rock. Here we go. Now for the proofs from section whatever, 5, I guess it is. Okay. So here's a proof. I'm going to erase that equal sign and I'm going to put an arrow on it, okay? So write that down and we're going to do this here proof based upon some of the things that are on the back of our note card. Got it? That are on the back of our note card. So, Um, I think this is, yeah, heck yeah, this is on the back of our note card, tangent a half x. All right. But the bad thing about this is there are two choices for tangent a half x, right? So what I need to do is go over here and think, what would the second to last step be? Remember that logic that we learned that you were going to use for the rest of your life? What would it look like if I was almost done? In any situation in your life, what would it look like if I was almost done? Okay, so if I can get 2 over sine x, boom, I got it. Okay, so if I look at the property for sine half x, I'm hoping that there's one that has sine on the bottom. Well, yippee, there is. 1 minus cosine x over sine x. Okay, now I have to come up with a property for cotangent, and you're like, oh, Mr. Blanchard, there isn't a property for cotangent. Well, no, but there's a property for tangent, and when I flip it, it's going to put sine on the bottom. Are you ready for this? Ba-na-na-na-na-na-na-na-na. Look at the first tangent half x property. It says sine over 1 plus cosine. So if I flip that puppy, it becomes cotangent. And so it's going to look like this. 1 plus cosine x over sine x. Well, looky there. Those common denominators already are ready to crunch together. And so this all goes together and just becomes 2. The cosines go bye, bye, bye. And then that's going to be 2 over sine x. Hey, look at that. That was our goal. Remember, this was our goal. How come the highlighter's not working? I just clicked on highlighter. Oh, there we go. Okay. Hey, look at that. That is it. So then we say equals to cosecant x, the 3 dots, and I knew, and here.
Hey everybody, this problem is done.
There we go. Can't wait to share that again. So that one is done. Here we go. Not dumb. It was done. It said done. All right. Number 26. This is still from 3.5. Okay. What in the world? Okay. So secant, I don't know what I could do for a step before that. What would the step before that look like? I don't know. Okay, so let's just start messing around with this. What do we know? We know when all else fails, try to get sine and cosine. I'm going to get rid of the x. That was my bad on the previous problem. I wrote the x's and I was just like, what? I just went with it. I didn't even point it out, but now I just did right there. I wrote all the x's, but I didn't need to. Okay, so now, what do I want? There are two choices for tangent half x. Maybe if I could get the sines to cancel out, because secant is 1 over cosine, yeah? Okay, so maybe that could be my goal. I don't know. Okay, so let's try to get the sines to cancel out. So I'm going to pick the second tangent half x property, which says 1 minus cosine over sine. And then the sines go bye-bye sine. Okay, so there it went away. And so now I have 1 minus cosine over cosine. And now I can split that puppy up. 1 over cosine minus cosine over cosine. What? That's awesome, because I wasn't even sure how to go about this problem. And that's secant minus 1. We proved it. And wait. Hey everybody, this problem is done. This is going to get more fun because I have to go through 1,000 problems today. You just wait. I hope it records well. I'm not even going to listen to it. So if it sounds bad, tough luck. It'll be like that video where I thought the writing was backwards and then I was thinking it was awesome. But it could be the same thing with this sound. Okay, so that's number 26. Number 27. Yikes, I'm not going to kid you here. This here is a tough problem. Let's try to go through it. Okay. I don't even know where to start. Okay, so there's two properties for tangent half x. I would love to be able to cancel out one of them, but I can't. Like I just can't. It's illegal math illegally, okay? So this is me stalling, thinking about what I'm going to do. All right, I'm going to write the 2. And I'm going to try the simpler denominator. Okay, I'm going to try the simpler denominator. And all that squared means this guy right here, that just means whatever you put in parentheses, just square it. Okay, so my thinking is maybe when I square the denominator, it's going to be a little simpler, and I will be happy with that. I'm going to leave the top alone, but now I'm going to mess around with the bottom because the top's pretty easy, right? We could do whatever we want with that, but I'm going to leave that. So now I'm going to do a little sidestep here with the denominator. That was supposed to be green. Okay, so now I'm going to do a little sidestep here. 1 plus, so I'm going to FOIL the top. Of course, everybody was going to FOIL the top. Yeah, right. And I'm going to square the bottom. Okay, that's cool. I'm going to turn this into sine squared over sine squared plus this. Well, I'm loving that. Da 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 da. I'm loving it. And here's why. You ready? The denominator is sine squared. I knew that was going to come in handy, keeping the denominator simple. The top is going to be 1 minus 2 cosine plus cosine squared plus sine squared. Ooh, ooh, looky there. Looky there. I got a bite. It's a country song, no big deal. Okay. Miss Witter listens to country music, I'm guessing. Looky there, I got a bite. Okay, so what is the yellow blob? The yellow blob is a 1. Right there. And then this one and that one make a 2. Very good. Okay, so this is going to be, remember, this is just a side step. 2 minus 2 cosine over sine squared. I hope you can hear that tapping. We haven't even started the new lesson yet. That's the scary thing. And we are, yahoo, 11 minutes in. It's okay. It's okay. It's okay. All right. The top now in blue, I'm going to go to blue because this is going to be the finishing color. The top is 2 and then 1 minus cosine over sine. The denominator is this guy, and that's 2 minus 2 cosine over sine squared. Ooh, I like where this is going. Okay, here we go. Here we go. Here we go again. I'm going to take this here 2, and I'm going to multiply it there. I'm going to multiply it there. So that's going to be 2 minus 2 cosine. Ooh, look at that. All over sine divided by 2 minus 2 cosine all over sine squared. And anybody with any part of a brain can obviously see JK, I joke, I kid, it's 721. This is still a very hard problem. I'm going to flip the denominator. The signs are going to cancel out, and that is going to yield what I was supposed to get, which was just regular old sine x. Wait for it. Wait for it.
Hey everybody, this problem is done.
Thank you, Darth Vader. Okay, and so is section 5. Wowza, wowza. Okay, that was tough stuff. This would be really, really mean for me to put on a test. But if Marshall is talking to Brock right now, I'm going to put it on the test anyway. I'm not going to say JK to that because I'm not laughing at that. I'm laughing at the truth. Okay, let's see. Oh, look at that. That's what we did in third hour class. We were graphing, we graphed this. And that was great fun. That was terrific. Don't you remember those days? But now look at the days that you're in. Look at that. Problem 27 on the left, what you used to do on the right. You have come a long way, haven't you? Okay, that's going away. There's Mindy the Wonder Dog. She's looking right at you. And we are going to this. Okay, so if you want to start a new piece of paper, I just laughed because look how I wrote the assignment. I wrote 1 through 15, comma, 16 through 22, because that is a special thing that I did. It should just be 1 through 22. That is cute. There we go. And then 25, 26, 41, 42, 45 through 50. Yikes, I think I have lost it. Okay, we are, I mean, A lot of people have been saying that for a long time. But we are moving on. Okay. Now you're like, hey, Mr. Blanchard, how are we going to do the problems if we don't even have any notes? Let's spend some time on the notes. I'm telling you this chapter is organized so well that us jumping to section 9, you're going to know exactly how to do all the problems already. I hope. Cross my fingers. I am right now. You just can't see me. Okay, let's fire up the note card. And let's pick up the pace a little. Maybe. Are we ready? I know you need a break just a little because that last one was wowza. That last one was tough stuff. Okay. I'm just glad I picked the right property because that could have been bad if I wouldn't have. Okay. Here we go. I'm just looking at the leaderboard for the golf tournament that we were talking about. Waste management. Okay. Hey, the directions are going to be solve for theta. I think. Yeah, solve for theta. Okay, so that means move that puppy over there. Tangent theta equals negative square root of 3. Now I'm going to use my note card. And I'm going to look in the tangent column for the square root of 3. I'm actually doing the inverse tangent of negative square root of 3. In the tangent column, I see it happening at 120. And I see it happening at 300. Well, yippee skippy. Let's move on. Oh, wait, no. Wait 1 second.
Hey everybody, this problem is done.
Thank you. I got to be careful moving this. And now we're going to the next one. All right, let's try this one. Hey, I'm going to move that over. So I'm going to have 2 cosine theta equals negative square root of 3. Then I'm going to divide by 2. And I'm going to have cosine theta equals negative square root of 3 over 2. Or if you wanted to sound really cool, you would just say negative root 3 over 2. And then I'm going to look in the cosine column on my note card for negative square root of 3 over 2. And I see it happening at 150. And I see it happening at 210. Wowza. Let's move. No. Oh. Hold, please. Thank you, mosquito. Next one. Oh, okay. Okay. Put a dot right here. Okay, let's do this. We can do this. Remember, please excuse my dear Aunt Sally. It still applies in trig world. So I'm going to get rid of this 2 first. Okay, so I'm going to get sine of theta plus 47 equals a half. I'm immediately going to do my note card. Okay, and it's going to be theta plus 47 equals something. I'm looking in the sine column this time for regular a half. It happens at 30, comma, 150. There we go. Okay. Now, what do you think I do with the 47? Anybody want to guess? Want to guess? Want to guess? Subtract it. Subtract it there. Subtract it there. And you're going to get theta equals negative 17, comma, 103. And you know it. You love it.
Hey everybody, this problem is done.
Sweet. Number 4. Okay, so another reason that I'm playing the little robot voices is because I know I'm writing fast, but I know that I got a lot to cover, but I know that you're also writing everything down. So I'm trying to stall a little. Click. Number 4. What in the Jack Russell Terrier am I going to do? Anybody? Anybody? Okay. I guess I should have previewed these notes, huh? Okay, I'm going to do the inverse secant, but I can't. So I would do the inverse secant of 2, but I can't. So I'm going to do the inverse cosine of 1/2. Do that. Do a little thinking there, everybody. Do a little thinking there. So it's going to be theta plus 81 equals, and now I'm going to put in the cosine column, I'm going to look for just a half, right? Yeah, just a half, which is 60 and 300. 60 and 300. Did you get my logic, what I was thinking of there? Because I wrote it down for you. Now I'm going to subtract 81, and I'm going to subtract 81, and I'm going to get theta equals negative 21, comma, 219. I know you're waiting for it. I don't know if I particularly care for that one at all. Okay. All right, so did you get my logic there for the cosine, everybody? Did you get my logic there? I hope you did, because it didn't take a whole bunch of extra thinking, did it? No. Ready, hike. Number 5, oh shucks, I forgot to write a theta. Okay. All right, put a dot here. This is number 5. You can't see it because I was trying to pay attention to the clock, but I got to put it away because it's bothering me, because I know I'm not even halfway finished, and that really bothers me a lot. Okay. I'm going to divide by 4. Now I'm going to do the square root of both sides. I'm going to get cosine theta on this side, and I'm going to get plus or minus a half on this side. Yikes. Okay, I need to explain that, don't I? If I said, hey, what's the square root of 9? You'd say, that's easy, it's 3. It's not plus or minus 3, it's 3. But if I said x squared equals 9, and then I said, what does x equal? Well, then you could say, well, it's plus or minus 3, because I could square 3, or I could square negative 3. Well, it's the same idea here with this cosine squared theta equaling 1/4. I did the square root of the top and the square root of the bottom and put a plus minus, which means I'm going to get some extra answers now from my note card, because now I'm looking for plus or minus a half in the cosine column, and I see it happening at 60. I see it happening at 120. I see it happening at 240. And I see it happening at 300. There we go. I hope you're happy with that one. I am. Oh, that might save some time if I use that one all the time, which means I won't. This is kind of hard to do because I have my paperwork kind of all over the place, and I have my note card. It's okay. I'm doing it. It's a sacrifice for you. You know why? Because I care. I care. Isn't that right, Lauren? I thought that my response to your email was very genuine yesterday. We all dearly missed you yesterday, Lauren. Next, number 6. Put a dot right here for times. I'm going to divide by 4. Okay, now I'm going to do the square root of both sides. Yeah. I'm going to do the square root of both sides, and I'm going to get sine theta on this side. And this guy's going to be plus or minus the square root of 3 over 2. Ooh, that's on the note card too. Maybe it'll show up 4 times and I'll have to find all 4 of them in the sine column. Let's do it, shall we? Because math. I see it happening at 60 and 120. This is cool. And 240 and 300. Hey, wait a second. Weren't those the same? What? Those are the same stinking answers. There's a reason for that. I'm not going to get into it. Okay. Are we ready for, whoa, 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 whoa. What was I thinking?
Hey everybody, hey, this problem is done.
Cool. I really hope the recording's working. Like, I really hope that you get to appreciate that. What am I doing here? What are we doing with number 7 but skipping? I won't put it on the test. I don't like that one because I already worked it out. I forgot to erase it. And then I don't want you guys to be super confused by it. Okay. See you later, number 7. We didn't want to visit you anyway. All right, go to number, oh, wait. No, I guess I can't play. I can't play it for that, can I? Shucks. Okay. Hey, have you noticed on all the problems on the right side, it's just been a number? See that? They've all just had a number on the right. Now look what happens with number 8. What in the Jack Russell Terrier is that? Why is the tangent on the right side? I don't know. So to move it, we're going to subtract it. Move it over here. Okay? So it's going to be tangent secant minus tangent equals 0. I don't know. I hope that works. I don't know if it's going to. Maybe I shouldn't have subtracted it. What if I would have divided it instead? We need to talk about that too, because there's something about getting rid of possible roots by division that's mathematically illegal. Okay, they're called extraneous roots, and they're a bad thing if you forget about them. Like, you can't, like, hey, I'm going to divide and get rid of that tangent. No, you aren't. You're going to factor out a tangent and leave this as secant theta minus 1. Okay, so now I have two equations. I have tangent theta equaling 0, and I have secant theta minus 1 equaling 0. So I really have secant theta equaling 1, which means I really have cosine theta equaling 1 over 1. I did that on purpose. And now I'm going to do the note card for both of them. I'm going to go tangent for 0, happening at 0, 180, and 360. Okay, and now I'm going to do cosine column for 1, and I have that happening at 0 and 360. I hope you do too. And then we're done with that. Okay. Now, if you're trying to follow along on the book, there's a lot of extra writing in the book that we aren't going to discuss until next week. Okay. So don't freak out about the extra writing that's in the book. Guess what? Guess what? Oh, that one could break the speakers. Number 9. I'm having a blast doing this. Okay, let's do it. I'm going to move this puppy over here. I'm going to get negative root 3 equals tangent x. X means radians, but for this year, for us, because we've survived so much, we're just doing everything in degrees, aren't we, for now? All right, look on the note card for negative square root of 3. I see it happening at 120 and 300. I hope I'm just going to put equals theta because x really means radians, and I'm not going to write them in radians because that's special. It's on your note card anyway, right? You had the conversions, but you don't have to worry about that. All right, 120 and 300. I don't know, Mr. Computer, what do you think?
Get up here, man.
What? That just said my words backwards.
Get up here, man.
Huh. But it really meant, hey, everybody, this problem's done. Next one, number 10. Okay. I'm going to move you over here. This is so easy, it's not even funny. Then I'm going to divide by 2. And then through the magic of me caring that little about radians right now, we're going to turn it into theta to degrees, and we're looking in cosine for 1, and it happens again at 0 and 360. If you want to write them down in radians, you don't have to, but of course it would be 0 and 2 pi. Duh. I hope you're really enjoying this.
Hey, everybody. This problem is done.
Cool. Next one. Number 11. Oh, thank goodness. Well, no, it's not different. Okay, I'm going to factor out a sign. Because I don't know how to solve it with sine squared and a sine. So, okay. So that's going to be 2 equations. Sine theta equals 0 and 2 sine theta plus 1 equals 0. Cool. This would be sine theta equals negative a half. I'm getting pre-calc fancy on you right there. I just did 2 steps in 1. And now I'm going to look for sine column for 0, and that happens 3 times again. 0, 180, 360. And then over here, I'm looking sine column for negative a half, and that happens at 2, 10, and 330. Dang. I was going to try to finish by 8 o'clock, but okay. That's from a movie, but I forget what it was.
Hey, everybody. This problem is done.
Oh, that kind of sounded normal, but it wasn't. It said faster. Number 12, factor out a tangent. I hope you can hear the tapping on the okay, there we go. Note card time. Tangent column for 0 happens at 3 places, of course. Love that. Tangent of negative 1 happens at 2 places. 135 and 315, that's pretty cool. You know why. Because it's the same numbers, just rearranged different. Pretty cool. No big deal. You guys can put squiggly lines there if you want. Also, if you're starting to get bored like me. Um, oh, we need to talk about the fact that you didn't know this song. Okay, not this part. Go ahead, snap your finger. You need a break. Hang on. Here we go. Come on. Here comes the loop. And I can't believe you don't know this song. Really? Nobody? It really bothers me that nobody knows this loop. Okay. Think about it. It deals with this. It deals with this right here on the screen. Got it? That's my hint. Figure it out. Oh, wait. No, 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 no. No, 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 no.
Hey everybody, this problem is done.
Thank you. Number 13. Oh, no, no, no. What in the... Okay, okay. Factor. Yikes. Okay, okay, okay. I can do this. I could down under factor, or I could guess and check. I could down under factor, or I could guess and check. I'm going to down under factor. What two numbers multiply to 4 and add to 5? Did you say 4 and 1? Congratulations, you're on the path to success. 2 cosine, 2 cosine, 2. A minus plus is a minus minus. I guess I'll put the 4 here and the 1 there. Then I'm going to factor out a 2 out of the first set. Like that. And then I'm going to go like this. And then I'm going to say that. I'm actually having to think a little here, everybody. Okay. Yikes. And okay, okay, okay. Wow. You ever hear that song that's called I'm Blue? Think about that for a second. That's all I gotta say. All right, this is never gonna happen. Cosine is trapped in between 1 and -1. You're not gonna get an answer of 2 ever trying to find an angle that yields a cosine value ratio of 2. That's just silly. But you will find cosine a half. You'll find a half in the cosine column occurring at 60 and 300. I love this. This is just a great, great assignment, isn't it? Where are we at time-wise? Good night. How long is class? Class is 50 minutes. Okay, 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 okay. We have to. Okay, okay. Let's keep going. Let's try to get through Um, ugh, ugh. Okay, let's go. Just stick with me for. Oh wait, the heck am I thinking? I'm getting so distracted.
Hey everybody, this problem is done.
Thank you. That is how my brain feels right now. Good night. Okay, I got an hour and 10 minutes before I go to sleep. Tomorrow is a LSD day. That just means long, slow distance, nothing else. Mr. Blanchard said tomorrow he's going to do LSD. No, it's long, slow distance day tomorrow running in the morning. If anybody wants to join me next week, I guess you could, because by the time you're listening to this, I will have already ran my long, slow distance. Okay. Number 14. Crud. Okay, let's try it. I don't know. I don't know. What two numbers multiply to 4 and add up to 3? Did you say 4 and 1 again? Congratulations. I think you made the right choice. We're going to do 2 secant, 2 secant, and 2. A minus minus is a plus minus. I guess the 1's got to go here and the 4's got to go there. That's cool. Terrific. Out of the second parenthesis, I'm going to factor out a 2. Bless you. Factor out a 2. That was funny. And then we go mark those puppies out. Okay, okay, okay. 2 secant plus 1 equals 0. It's really 2 secant theta. And then also secant theta, I'll put it there because I forgot it on the other one, but I'm not going to go back and fix it. So that I can fix it now. Secant theta equals -1/2. And secant theta equals 2. And you're like, Blanchard, we don't even have a secant on our note card. And I'm like, no, duh. So this would be cosine theta equals -2. Not going to happen. We've already had that discussion. And this would be cosine theta equals 1/2. And cosine theta equaling 1/2 occurs at 60 and 300. Okay, I really need a break, and so do you, and plus class time is almost up. Sorry about that, everybody. Don't do anything else. Like, take it easy this weekend. If you're one of those nerdy people that feel like they just have to work ahead, go ahead. If you really want to, you can. Not gonna lie, if it was me in high school, I would have. But you don't have to, okay? We aren't gonna test until Wednesday, which means we have Monday and Tuesday to finish this mess. And with that, I say to you, good day.